Mana mana. Mana mana. Mana mana. Mana mana. Mana mana. Mana mana.
1.5 measuring and constructing angles. And actually in this video we're not going to construct angles. We are going to measure and classify angles, however. So your essential question is, how can you measure and classify angles? Well, before we get started, let's talk about what an angle is and how we actually name angles. So an angle is a set of points consisting of two different rays that have the same endpoint. All right, so as you can see to the right here, I've got a ray AC, that's one ray, and a ray AB, and they meet at their common endpoint. That's forming an angle. So where those two rays meet, that's what we actually call the vertex. And the rays are the sides of the angles. Now, you can name an angle in several different ways. Just like we could name a plane different ways, we could name a line different ways, we can also name angles in various ways. So one way to name an angle is to use its vertex. So I'll put a number 1 here. So this angle to our right, we could name this angle A. We could also use a point on each ray and the vertex, such as angle BAC and angle CAB. Notice that the vertex has to be in the middle. The vertex is in the middle. Otherwise, this doesn't work. And then any point on the rays go on the outside. So that's the second way that you can name an angle. And the third way, if you happen to have one, is to use the number. You can see here that we've got the number 1 in the middle. So we're actually able to name this angle, angle 1. So 3 different ways to name the exact same angle. This next section talks about the region containing the points between the sides of the angle is the interior. So you can see this red section here. That red section is the interior of the angle, and everything outside of that interior contains all the points outside the angle is what we call the exterior of the angle. All right, so let's practice naming angles. So we have this angle here, and we're going to write 3 different names for this angle. And we'll use these 3 different ways of naming an angle from above. So first, we can just use its vertex, as long as it has one. Well, I can see that the 2 rays that form this angle meet at point U, and that is, in fact, the name of the angle. That's its vertex. So we can call it, the first way, angle U. The second way, we can use a point on each ray and the vertex, knowing that the vertex has to be in the middle. So again, U is our vertex. We can make sure that the vertex is in the middle, and then we can use any point on the 2 rays. So I can call this angle VUT. Now these are all capitals. Or I can start with T, so angle TUV. That's the same angle. I just used the points in different orders. But notice where the vertex is. Vertex is in the middle. And the third way, which won't always be possible, but since we are given a number in this angle, we can call this angle 3. So those are 3 different ways to name the exact same angle. So measuring and classifying angles. Normally how we measure an angle is by using a thing called a protractor. And there is a diagram of a protractor here that we're going to use. So they're going to be in our paper. But it helps you approximate the measure of an angle. And the measure of an angle for right now is usually given in degrees. Later on we'll measure it using radians. But for now, in degrees. We recently learned about the ruler postulate, where if I had a segment, let's say, and I had some endpoints on that segment, such as x1 and x2, then I could take a ruler and put that ruler up against those two endpoints, whatever those values were, maybe they were like 5 and 7 or 10 and 12, whatever it was, I could then find the length between them by subtracting the coordinates and making sure that it was positive because I was looking for that length or that distance between them. Okay, so this is the ruler postulate. Well, now we're going to do a similar thing for the angles, and we're going to use the protractor postulate. So the protractor postulate is a way for us to measure an angle. And before we get started, let's talk about what the notation is for measuring an angle. So the measure of an angle, we could write like that, or we can write it with a little m in front of the angle name, such as m of angle AOB. And that basically means the measure of angle AOB. And the way that you find that measure, if you're using a protractor, is you take the absolute value of the difference between, and they're using real numbers because it has to be real numbers because imaginary numbers we can't use. Okay, so between the real numbers matched with ray OA and ray OB on a protractor. So you should see ray OB to the right here. You see how it intersects some numbers on that protractor? And then you also have ray OA, which is the other side of this angle, and it also is intersecting some numbers on the protractor. And so to use the protractor postulate, we would basically take the difference between those numbers and do the absolute value so that we make sure that we end up with a positive angle measure. I'm going to use a couple colors. If I start with those inside numbers, so if I start with 0 and 140, then I can find the measure of angle AOB by basically taking the difference, the absolute value of the difference of those two numbers. And I can see that the inside numbers follow this line if I open counterclockwise from 0 to 140. So I can take 0 and I can subtract 140. Subtracting those gets me negative 140, which is why I use those absolute values to make sure that I get positive 140. So our degree measures right now will always be positive. So I can use those inside numbers. I could also use those outside numbers. I can see 180 here and then 40 here, and if I follow those numbers around, I can see that those relate to one another. So I could also say that the measure of angle AOB is equal to the absolute value of 180 minus 40, which again will give me the absolute value of 140, which is 140 degrees. Either way works, and I can switch up those numbers as long as I stay either on the outside or on the inside. The order of the numbers does not matter. Now let's classify angles according to their measures. And I don't think any of this is new to you. I am going to introduce a little bit of new language for you. And the first is this. This is theta. Theta is a Greek letter, and we usually let theta represent the angle measure, or the measure of an angle. So this is going to be the measure of an angle. So it's a nice variable that we can use to represent the measure of an angle. So as you've probably learned in the past, an acute angle is an angle that measures greater than 0 degrees and less than 90 degrees. And I'm going to use a compound inequality to represent that. So if I have an acute angle, theta, it is somewhere between 0 degrees and 90 degrees. If I have a right angle, theta would equal 90 degrees. It's exactly 90 degrees. If I have an obtuse angle, well, that is an angle that measures more than 90 degrees, but it's got to be less than 180 degrees. So that would be a theta greater than 90 degrees and less than 180 degrees. Because if it's 180 degrees, then we call that a straight angle. So a line, that's a straight angle, and that measures 180 degrees. It's exactly equal to 180 degrees. Okay, now taking these two things, the protractor postulate and the different types of angles, we are going to measure and classify angles here. So I've got 3 angles that I'm going to measure and then classify. And I'll use different colors. So let's start with angle RQU. All right, so for A, I'm going to go up here. We're going to find the measure of angle RQU. So first I'll start with that protractor postulate. So let's find the 2 rays that make up angle RQU. So I can see that angle RQU has one ray that is QR and the other ray is QU. All right, so we have to figure out where these 2 rays intercept that protractor. And I can see that we're down here, and I can either use the inside or the outside numbers. And I can also see that we're somewhere up here between 50 and 60, or 120 and 130, depending on which numbers I want to use. How about I use the 180? So I'll use those outside numbers, 180 all the way over here. Between 50 and 60, you got to think about which way those numbers are going. So from 50 to 60, it looks like it's going to be 55 degrees, okay? Or if I went the other direction and use those inside numbers, it'd be 120 to 130, so it'd be 125 degrees. So you kind of have to look at like what order are the numbers going in. All right, so I'm going to use the absolute value of, and why don't I start with 180? And then from that, I'm going to subtract that 55 degrees. I'm using the absolute value to make sure that I always get a positive number. Well, 180 minus 55 is going to give me 125. And it is positive, so that worked out really well for me. So that's 125 degrees. I didn't actually need the absolute value symbols, but that's part of the protractor postulate and making sure that we end up with a positive measure. All right, in addition to that, I need to classify it by its measure. So that's a 125 degree angle. It's larger than 90 degrees, so it's not a right angle. It is an obtuse angle. So I'm also going to call it obtuse. Now let's look at B. So now I'm going to look for the measure of angle TQU. All right, so it looks like TQU is this angle here. And why don't I stick with those outside numbers? So I'll continue on with my 55 degrees. How about I put that one first? And I'm going to subtract from it. It looks like this is going, this ray, QT, is intercepting 90 degrees. And 55 minus 90 is negative 35. So it's the absolute value of negative 35. Or in other words, that's 35 degrees. And a 35 degree angle is a small angle. It's less than 90 degrees, but greater than 0 degrees, because if it was 0 degrees, you'd have no angle. And so that's going to be an acute angle. All right, our last angle, I'll put over here, is angle UQS. So the measure of angle UQS. Okay, so it looks like I'm still using ray QU. So this one here, which was at 55 degrees, if I'm using those outside numbers. And then QS is over here. And it looks like it's going between 140 and 150. So we can say that it's 145 degrees. So this angle measure is going to be 145 minus 55, or 55 minus 145. We're taking the absolute value, so it doesn't really matter. And you're going to end up with 90 degrees, absolute value of 90, or 90 degrees. And that is classified as a right angle.
Mana mana. Mana mana. Mana mana. Mana mana. Mana mana. Mana mana.